Okay, so we are on the second problem for hypothesis testing. I believe the first one may have gotten cut off. We end up with the same conclusion here, so I'll jump back to it with that problem. But anyway, this hypothesis test is about a claim against means. So a public bus company official claimed that the mean waiting time for bus number 14 during peak hours is less than 10 minutes. So we're comparing against 10 minutes. Karen took bus number 14 during peak hours on 18 different occasions. So Karen took it on 18 different occasions, sample size 18. Her mean waiting time, so her average, the sample, was 7.6 minutes. And with a standard deviation, her standard deviation, so not the population standard deviation, but her sample standard deviation was 2.3 minutes. At a significance level of 0.01, so it's very small, 99% confidence. Test the claim, so here's the claim. Test the claim that the mean waiting time is less than 10 minutes. So that's the claim, that's the alternative, that the mean is less than 10 minutes. So if that's the alternative, the null must be that it's equal to 10 minutes, because our null always has a statement of equality. So with this sample information, we need to calculate the test statistic. And in this example, the test statistic will be a t-value because we do not know the population standard deviation. So this is going to be a t-test. So I can use the calculator to run a t-test. Go down to t-test. Input all of these specific values, the mean value of 10, the sample mean of 7.6, the standard deviation sample is 2.3, and 18 is the sample size, and we are testing less than 10 minutes. And I'm actually going to draw this to see what it might look like. And these values are kind of small relatively, so it might take a little time for it to sketch. But regardless, it's going to look like a t distribution, which is almost normal. And we get some outputs of negative 4.43, negative 4.43 for our test statistic, and our p-value of 2e to the negative 4. Now, I'm going to quickly sketch it so I don't have to keep going back. Basically, it's just a little bit over here, and our test statistic is here, and our z alpha is there. Sorry, our t alpha and our t. Excuse me. Our test statistic is to the left. It's in the critical area. What does 2e to the negative 4 mean? That means 2 times 10 to the negative 4. That means I take my 2, I have a decimal place, and I move it left 4 times. So I need to put some zeros in there. So it's actually equal to 0.0002. So the p-value is very small. Very small, and that is much smaller than 0.01. So the p-value is smaller than alpha. So if the p-value is smaller than alpha, we are going to reject the claim. Sorry, we're going to reject the null hypothesis. So we reject the null hypothesis, which says that the mean wait time is equal to 10 minutes. That's what we're rejecting. We are rejecting that. So if we're rejecting that, we are saying a big yes to the claim. So we would say there is statistically sufficient, or just sufficient evidence to support the claim. We are supporting this claim that the mean wait time for bus 14 is less than 10 minutes. So yes, that is our final conclusion for this hypothesis test. So in conclusion, I've covered at least one or two problems on every topic that we've covered this class. You've done this over and over again. So this is the last review problem I'm doing. Besides this, you might want to look at a problem on correlation coefficient. I've referenced it on the final exam topic sheet. And follow any other links that you may find on these topics. If you have any questions, please reach out and ask. Every single topic that's on the final exam review topic sheet will show up on the final exam. So please do not hesitate to ask specific questions that you may have. If not, I will see you in just over a week for your final exam. Take care, and I will be sure to take pictures of our new edition.